Today, as it says right up here, we're going to talk about fractions. Fluency and fluidity, whatever the heck that means. But so here's what we're going to do. Here's what I'd like to do. I want to spend a little time defining some terms, share some evidence of how our kids are kind of up and down and over and sideways with fractions. Quick review of the research on why, and then spend a little time looking at how technology can help try and remedy some of the issues that our kids seem to have. So a lot of this is going to be research drawn from the development of a program called Fractionation, which is coming out the end of the year or January, I think. So we poured through a lot of research and had a lot of did some of our own research on this, and it's kind of interesting what we found. So what do I mean when I say fluency and fluidity? So fluency is accurate with little effort. When we talk about of cognitive load, if something is laborious, I'm not fluent with it. If it takes me a long time, I have to work it out. But things that come very easily, and that includes things that are kind of automatic, but also things that are just routine. I know how to do this. So if you take a fraction like 9/4, for instance, and we'll see how fluent you are. So you guys can just do little call-outs here. So between what two integers would you find 9/4? 2 and 3. See, that was pretty good. That was not, you guys didn't labor over that. Is it greater or lesser than the halfway point between 2 and 3? Less, yeah. What's another name for it? You guys are good. And this is not surprising, because it's NCTM, but it's reassuring. If you multiplied a whole number times 9/4, would it make it greater or lesser? Greater. That's pretty good. Mostly, a lot of times kids think you multiply by a fraction, it makes it smaller, but not all the time. But you guys are fluent with this stuff. This stuff comes very easily. So we'd love our kids to be fluent with this kind of stuff with fractions. They see a fraction, they know, they have a sense of how big that is, where you'd find it on a number line, other names for it, what it would do to other numbers. That would be great. Okay, by fluidity, think of fluid. Think of water. You can often use the word flexibility, and you still get the same alliteration. But I like fluidity because it's like water. It doesn't have to follow a straight line. No matter what is in front of it, it kind of finds its way. And so we want kids to be able to change with ease. So when they see a fraction, they're able to go from one representation to another with that fraction. It's like, I still see that that's 9/4. Not a problem. I can go with the flow. I see it in a different context, often in unfamiliar format. And I still see, oh yeah, I can still see 9/4 there. And I have lots of different ways for thinking about it. So I can be fluent down a narrow path, but we'd like our kids to be fluid and be able to move and represent and recognize and adjust to when things don't look like the way I just got taught. So this is what we're after, fluency and fluidity. So how are we doing on that? So here's an item from 2007 NAEP, grade 8, labeled low complexity. In which of the following are the 3 fractions arranged from least to greatest? And 49% got it correct. What's the correct answer? Start at the top and stop there. Right now, if we were, if our kids were really fluent, maybe even if we were a little more fluent, you start at the top, and this is like, boy, this is cake. We have a benchmark right in the middle. And the fraction to the left of the benchmark, is that less than half? Bingo. Is that more than half? Bingo. Done. These guys, most common incorrect answer, they went all the way down to the end. What were they thinking? Because I don't get it, because this is the only one where it goes from greatest to least with both the numerator and the denominator. Because I was expecting, well, they'll probably do B. But they didn't. So I'm trying to think, what's going on? The only thing I can think is that kids went down the list, got to the end, said, I have no idea, and circled that one. So we're not there. Because you should be able to stop right here. Which one? Bingo, done. I don't know. I'm confused, and I have not seen an analysis of what went on. Now, we're not there. We're not there. Now, it's not all bad. 89% of 8th graders got this one right. What fraction of the figure was above in the question, but I didn't have room, is shaded? And they were able to say that 6/20ths is the same as 3/10. 89% got that. It's like, OK. Now, I'll show you an item later that going in the other direction, they're not that good. But matching a picture to a fraction, at least this one, 89%. 89%. So that's still 11% of 8th graders. 8th graders. It's a pretty simple question. So we went and started digging. What's going on? What are kids thinking? And there's a lot of research out there. We wanted to see it for ourselves. And so here's Pat. Pat is not the student's real name. And I picked Pat because you don't know. It's like Saturday Night Live, Pat. Boy, girl, not sure. But Pat, grade 6. Here's a simple, it's an addition of fraction problem. And look, Pat was so perfect. 1 + 5, 6th. Kept the denominator the same. It's like, simplified it. Pat's got it, right? Pat's got it. You look at that item. Let's try another item, Pat. 6 7/10 subtraction. Pat has so got it, doesn't even need to show the work. 2 4/10, simplify that to 2 2/5. Now, if we stop here, we think Pat's fine, right? So here's Pat again, 7/10 + 3/5. Now, what happened, Pat? You were keeping the denominator the same before. Now the denominators are different. All of a sudden, you add them. No idea. It's OK, how about this? 3 5/8 minus 1 7/8. 5/8 minus 7/8, 2/8. All right, so maybe Pat doesn't have it. 6 1/3 minus 2 1/2, 4. I have no idea what to do. 1 minus 1 is 0. There's nothing there. 1/3 minus 1/2? Can't do that, right? So Pat, as you dig a little bit, and all of a sudden you find that Pat doesn't get it. And our tendency there is to say, oh, we just have to teach Pat how to borrow with fractions or something. But that's not it, because if you really understood that, you'd know this does not make sense. And in life, if you gave a bar, in their informal life, if you had 1 1/3 minus 1/2, you'd know that there's stuff left. You'd know. If you had 1/2 and minus 1/3, you can do that. What you don't know is what the heck is the name of that. And but these guys are caught up in the algorithm. So it's not uncommon to have this sort of what looks like spotty understanding, where students are able to do something, but not a lot of other things. You dig a little bit in there, and you have this sort of false positive. If you just look at those first 2 items, you go, Pat's got it, knows fractions, but not really. And so you have this gap that we often see between what kids do informally, what they do in their life. They know that if you add 1/3 and 1/2, you get to some amount. They don't know how to name that amount, and it's not going to be 2/6 or 2/5. Sorry, 1/3 and 1/2. So they have some informal grasp of stuff, and I'll talk a little more about that in a minute. But their formal application of it is shoddy. And typically that's because they're not fluid. They know what to do when the denominators are the same. They may be fluent with adding fractions of the same denominator. They can whip through it like this. Pat was fine. I know how to do that. I have this procedure down. But they do not have the conceptual understanding to do it when the denominators aren't the same. They don't really understand what those fractions are. So we have to be careful that we're not satisfied with just that speed of a procedure. We got to make sure they really get it. Steve Hecht has done some research to try and dig down, like, what's going on here? What's happening?